So good morning, everyone. My name is Juan Martín, and today I'm going to present our work, Speech Emotion Recognition for Call Centers using Self-supervised models, a complete pipeline for industrial application. This work was done as a collaboration between Vicomtech, the Basque Country University, and two companies, Natural Speech and React. So this is an overview of my presentation. First, I will introduce the objective of this work. There is a project to develop speech emotion recognition models for call centers. To this end, we will annotate and prepare an emotional corpus for this specific domain. After describing the corpus, I will present the experimental framework and results obtained for the training and evaluation of the different models. And finally, I will summarize the conclusions and future work. So as I previously said, this work borns as a collaboration between research and industry to develop and transfer speech emotion recognition models for call center domains. Companies are interested in this kind of models because they can bring different benefits, for example, helping in issue resolution, improving the communication strategies of the companies, and at the end, offers a better customer satisfaction. The problem is that the application of these models have very different challenges. For example, the robustness of this kind of machine learning models on real-world applications, the lack of speech resources for this particular task, the fact that we are dealing with conversational speech, and of course, the precision of state-of-the-art models, even in benchmarked research databases due to the subjective nature of this task. So your objective here is the development of an emotional corpus that allows us to train machine learning system, in that case for two particular use cases in Spanish call centers. One more dedicated for customer support and problem resolution, and the other one for debt collection. So for this task, we were provided with more or less 60 hours for in-domain speech data from the call center companies. Before annotation, we have to pre-process the corpus doing different tasks like speech activity and overlap detection and speaker diarization in order to obtain appropriate audio segments to train the models. The privacy nature of this data prevents us from using external services or crowdsourcing approach for the annotation. So in order to maximize the amount of annotated data, we relied on two annotators by segment, in that case, taking advantage that they were experts trained by the companies in this task. So these annotators were asked to us to annotate, two different kinds of emotions. Categorical emotions, for example, calm, nervous, and noise, and also discretized dimensional emotions in two different dimensions. Arousal, that are different excitement grades for the speaker, and also balance, discriminating between positive and negative emotions. In these figures, we represent here the different annotated emotions on the first phase in the balance arousal plane. Then to define the final ground truth labels of the database, we follow the next criteria. First, we remove classes with low representation, for example, surprised, unsatisfied in the depth domain. Then we merge high correlated labels, for example, here, angry with annoyed, with merge, also some string dimensional motions with the closed one. And finally, in the case with annotation disagreement between the different experts, we prioritize the emotional levels in order to train models that can better detect that kind of states. After this procedure, we end with the amount of data in number of samples and hours for the different dimensions and classes. In order to deal with the unbalanced nature of the data and also have the possibility to deploy models less discriminative but with better performance, we prepare two versions of the database, one with full annotation of the data and the other one only for binary classification, differentiation between neutral and emotional states. We evaluated in the resulting call center corpora as well as the well-known EMOCAT corpus. There is a 12 hours after emotional corpus. In that case, we consider the categorical emotion classification. In both cases, we use five-fold cross-validation, with each fold considering different conversation, speaker, and also stratified levels. And the different systems were compared in terms of the micro-average F1 score. As input features, we consider both traditional features commonly used in this kind of emotional detection task, as well as these features for different domains, for example, speaker verification, linguistic features from a Spanish bird model, and very recent acoustic supervised features for well-known models like Wat2Vec2 or WAVLM. For the backend classifiers, we consider both a very simple support vector machine and also the neural network downstreams using either statistical pooling or identity correlation pooling. In both cases, considering different strategies to deal with the imbalance of the data. The results for the EMOCAP database show that the best performance is obtained using the acoustic supervised learning models, with very close results even for the support vector machine or the neural network classifiers. And in that case, for these last models, we obtain similar results with the state-of-the-art models, considering only a speech signal. To obtain more insights about their results, for the best model, we saw here the confusion matrix, where we can see that the most of these classifications happens between the neutral and remaining emotions. Then we evaluate the different approaches in the call center corpora, training different classifiers for each of the dimensions. And here we can observe the results for the full and binary setting of the database. We observe that we obtain again competitive performance with the acoustic supervised models, and also a very simple support vector machine can yield good enough results in this task. In the case of the depth domain, we observe that similar tendencies are obtained across the different dimensions and settings, probably showing some correlation between the different kind of dimensions. While on the other hand, in the support database, we observe that the results are commonly, or the performance is lower, especially or even when we observe the binary setting, probably due to this is a more challenging domain with less emotional content. To also obtain more information about what's happening here, we obtain here the confusion matrices for the best performing model. In that case, for the categorical dimension, we observe that there is a high confusion in underrepresented classes, for example, nervous when annoyed or satisfied with calm. While in the case of dimensions, the main confusions happen between adjacent levels. For example, very negative and negative emotions, and normally with the more extreme emotions. We also support our idea of developed binary classification models. Finally, to further validate these models on a real application, we perform an additional subjective analysis, in that case with a test of 15 conversations from the depth domain. In that case, we have two evaluators, one only listening to the audio and performing manual annotation about the emotional states of the client or agent, and the second one that only had access to the automatic description provided by the emotion detection systems. Both analyses were compared in general aspect about the evolution of the emotions in the conversation. The results show that 100% match was obtained, considering that we have 10 out of 15 emotional conversations. We also validate the good performance of this kind of system in a practical case. Also, the second evaluator highlight that the multi-class model was very useful for the arousal and balance annotation to describe the temporal evolution and the identification of the strong emotions, while binary models were preferred for the prediction of the categorical emotions. In the end, the company detected the following use cases with this model can have potential applicability. The identification of calls with very negative emotions from part of the client, the analysis of the emotional evolution during the conversation, and the evaluation of the agent's performance. So as final conclusions, this work saw a successful collaboration between research and industry to address the speech emotion recognition in the call center scenario. We were able to create an annotated emotional corpus for these two use cases in this domain, and also develop competitive emotion recognition detection systems with different prediction levels. The subjective analysis showed that these models have a potential applicability in commercial use case for the companies. And finally, for future work, we will further investigate in the integration of these models in an active learning framework that help companies to annotate additional emotional data. So that concludes my presentation. Thank you very much for your attention.